So welcome for today's lesson. So there it is titled projectile motion. So what is this projectile motion? Yes. So according to the document, the summarized document which I've shared or I will share in the group, there it says projectile motion describes the motion of an object launched into air and affected only by gravity. The object path is parabolic with the horizontal and vertical motion analyzed separately. Key cases include horizontal projectile, upward projectile. So me, I don't like memorizing or sentences or the definitions, but I'll try to make it simple so I can say it is the motion of two dimension. So if you have launched, like here, that is our example. Let's create our dashboard. Yes, so let's create here. I hope you have seen the picture. So I can say projectile motion. I can just give an example. You have launched, this is the object. You have launched through upward, then the object will be here. Or this is a person, for an example, throwing a stone. So the stone will just move, go this side, and then come back down to the ground. So that is what we are calling projectile motion. It is a motion of two dimension. So there the object is moving upward, and there it moving like this. So both upward and going to x-axis and y-axis, they are affected, and also the gravity is also affected. So that is from our projectile motion. So projectile motion, it is simple. So in today's lesson, we'll consider cases which deals with projectile motion. What are those cases? So even in projectile motion, we have what we are calling cases. So the first case is where, which we'll consider today, this is a cliff. Just this is a cliff. Example, this is a cliff, and then you are standing here. Okay, I'm not an artist, but I'll try to draw like this. You are standing here, you throw a ball, you launch, or not like this, like this. Okay, so you launch a ball, fall like this. So that is the first case of projectile motion. There are three cases. This is the first case. We learn that first case, it is simple. And the second case which we learn, it is like this. So this is our first case. The second case, you may be on the ground like this. This is the ground. So this is our ground level. So here you can be on the ground. You throw, or the ball is launched upward, going down. So that is also projectile. From this is the ground, you throw a ball launched until downward. So also as formulas, you are standing there, yes, on the ground. And another also, which is another case, it is where you are standing also the cliff. We'll try to answer also different question. There, this is a cliff. So this is what you are calling a cliff. So you are standing on the cliff there, or you project an object, goes upward, then comes down. So that is the third cases. If you know this projectile motion, then all questions which they will ask you, it will be very much easy and simple. So our today's lesson will just consider the first case of projectile motion. What are these? the first case of projectile motion, which I shared at first. So the first case of projectile motion looks like this. A person standing on the cliff like this, then the object is thrown downward like this. So that is the first case. I don't want you to memorize formulas. I want it to you need to know where the formulas came from, or develop the formulas together. No need to memorize, because sometimes in the exam you can forget the question, but if you know where they came from, it will be very much easy for you. Yes. So sometimes they can ask you to find what? E, the height. That is the first case, because all formulas, they are different according to the cases, but you need to know where those formulas came from. Yes. So this is, we are saying this is height. How can we find height? You need to know now. What do we need to know? So you need to know the formulas of motion in one dimension. So what are those formulas of motion in one dimension? We learned this. Those who are in private group, they have the idea of the formulas of one dimension. So we said V. So we start for the distance. We say x is equal to what? V initial t plus half gt squared. So they give these formulas. So these formulas they give. So which is x is equal to v initial t plus half gt squared. That is the first formula. Or if some of you are used to say s is equal to v naught s plus half a t squared. Now you know this. We can say, let's delete first up the other diagram. So when we're dealing with projectile motion, we are dealing with gravity, not acceleration. So because you are throwing the object there, we'll not write what? We'll not write acceleration here. Like s is equal to v initial t plus half a t squared. So we'll not deal with the acceleration. We'll replace g, because gravity. Yes, the same unit for acceleration, the same unit for gravity. So that's why we're writing x v naught t plus half a t squared. Yes, so that is the first formula. Yes, now we have three formulas for motion one dimension, which is also v final squared is equal to v initial squared plus 2gx. So gx, there you sometimes will say 2as. So v final plus v initial plus 2as. Now 2as there. In projectile motion, we will not write a. We denote it by what? By g. Yes. So do not be confused there. It is simple and straightforward. We only use the formulas for motion in one dimension. That is the key. If you know the formulas of motion one dimension, it will be very much easy. Even we should not even memorize those formulas, because they provide in the question paper. Yes, the last one, which is v final plus v final. Can you say v final? Yes. So v final, v initial plus gt. So here it says v is equal to u plus at. Now we replace gt. Yes, that is, you need to know those three formulas. This the second one, and the third. Those are the key formulas you need to know. Yes. So now we are dealing what? Motion in the first case of projectile motion. Let me write the first case of projectile motion. So the first case, yes. So the first case of projectile motion there, it looks like what? So the first case looks like this on the cliff. Yes. So we denoted on the cliff there, and there the ball comes like this. So that is the formula for, well, that is the first case of projectile motion. Now they can ask you find the height. Find the height. They ask to find the height, to find the time, and to find what? Yes, and to find the range. That's the only thing which they'll ask you. So to find the range. So here we develop different formulas how we can use in first case of projectile motion. So how can we find the height? We use the formula for motion one dimension. The same formula, it is the same. No need to change anything. So just recall the formulas for motion one dimension to find the height. Yes. So what formula can we use? We use any formula. You need to pick any formula, but this will be very much easier for you, which is x is equal to v naught. Yes, so v naught times time plus half g t squared, because there x, there we can say it is just the distance h. So h represent also the same, we represent the distance. Yes. And when you look at there on the cliff there, when you throw an object, it hasn't started moving. So there velocity initial is what? So it should be 0. Then here the object will not move. At start the object will not move. So velocity initial will be 0 until it reaches the final. Yes. If you have held the ball is not moving. So velocity is 0. So there here velocity initial will be 0. So which is x. X there it will be what? Just the height which we want, because it's a distance on the y-axis. So velocity initial is 0. Then we write half g t squared. So that is the formula to find height in this first case. We just need to know those formulas for motion in one dimension. And another thing which they can ask you, it is to find time. Yes, if you find time of this, how long did the boat takes to reach the ground? So they ask you the time taken for any boat to reach the ground. They can ask you different questions. So let's delete how can we find the time, because we are looking, we want to find here the height, we know the formula, the time, and the range, we know it. So now how can we find time? We just drive this formula. So this is the formula. Yes, so this is the formula, we just drive it. So here it says h is equal to what? Half g t squared. We just make time the subject of the formula. Yes. So if you make time the subject of the formula, we develop the formula for time. So just make the time for subject of the formula. So there will be 2h is equal to gt squared, because 2 times there, so over g, yes. So t squared is equal to 2h over g. Finally, yes. So cancel. So t will be what? 2h over what? Over g. So that is the formula 2h over g. So not forget here square root this. So that is the formula for time. That's all. So you just need to know the formula for motion in one dimension. So any question they will ask you, it will be very much easy and simple for you. Yes. Now let's go to the range. Last thing, the range. Yes. So the range. So the range, I can say it is the same as distance covered in x-axis. So here x. So this distance in x, we just called the range. So this distance which is covered, the object, the ball is moving, but the distance which is covered in this x-axis, that is what we are calling the range. And we know speed is equal to what? Distance over time. And there we just want the distance. So we just say, so what is distance? So just cross multiply. So distance is equal to speed here denoted by velocity times time. Yes. So that is the range. So this is simple and easy. So this is where we end. For more information, I want to continue this video to enjoy the lesson. You just join our website. We upload the next video. Thank you for watching.